Okay, welcome to my channel. I'm Hamza Ria, and today we shall be having another presentation of this house and land price predictor model using AI. The contents of this presentation shall include the description of the problem that we're going to address, how the dataset that I chose to help out to solve this problem will be used to address this problem in particular, factors I considered when choosing this dataset, features the model will use from this dataset, and also we shall go through Bayesian theorem, naive Bayes, and Bayesian networks. We shall also go through Bayesian, the differences between Bayesian theorem and naive Bayes, and that between naive Bayes and Bayesian networks. So let us commence. The problem that we are going to be solving, that we're addressing, is that of unfair pricing of houses and land in society. This problem has resulted into a biased environment when it comes to real estate, and causes people to, it causes buyers in some cases to pay way more than they should for housing and land, and vice versa for sellers being taken advantage of when trying to deal in this business. This damages the current view of the economy and also the general state of real estate as a whole. The data set that I'm going to be used to solve this problem is Japan real estate prices. I got this data set from Pago, and this data set, the reason why I chose it is because it has information relating to land and housing, which can help this model accurately predict the prices of housing and land. Factors which I considered when choosing this dataset. The size of the dataset was key, as this dataset has data from 2005 to 2009, and this it reduces the space for bias when trying to predict pricing of housing and land. Number of features in the dataset. This dataset had a large number of features that were affecting the price of housing and land. Some features include area, land shape, etc. Balance of the dataset. A balanced dataset gives the price prediction model higher accuracy levels. This dataset I used was said to be balanced in its description, and thus I decided to choose it. And also relevance of the dataset. I found this dataset to be relevant because it was used, it has different pieces of data relating to real estate, and we're trying to address a problem that is being faced in real estate. Important features the AI model will use in the dataset: area, purpose of the housing and land for future use, city planning. These are the districts designated by the City Planning Act of Japan. It could be the residential areas, industrial areas, such and such. This affects the person with purpose of future use. Region, these are the characteristics of the surrounding area. For example, swamps, lakes, beaches, such and such, they affect the price. And type, real estate types, as shown in the presentation. Bayesian theorem. This is a method for calculating conditional probabilities. We learned it originally in math, and we're going to be applying it in machine learning. It helps to determine the probability of an event using random knowledge. It's one of the most popular machine learning concepts, and it helps to calculate the probability of one occurring event with uncertain knowledge while another one has occurred. This is where we bring up conditional probability. Bayes' theorem can also be derived using product rule and the conditional probability of event X with known event Y. The formula is as follows in the presentation. Naive Bayes is a probabilistic machine learning algorithm that is based off of Bayes' theorem. It is a classification algorithm that is suitable for binary and multi-class classification. I'll go into this more into the next slide. It is a supervised classification technique that is used to classify future objects by assigning class labels to instances using conditional probability. This is where we apply Bayesian theorem. In supervised classification, training data is already labeled with a class. In many practical applications, parameter estimation for naive Bayes models uses the method of maximum likelihood. In other words, one can work with naive Bayes model without accepting the Bayesian probability or using any of the Bayesian methods. This is important as it's one of the differences between Bayesian networks and naive Bayes. Bayesian networks is a probabilistic graphical model that represents a set of variables and their conditional dependencies using a directed acyclic graph, which we can call DAG to avoid those big words. Bayesian networks are ideal for taking an event that occurred and predicting the likelihood that any one of the several possible known causes was a contributing factor. I'll get into this more in the next slide. The causal probability relationships in a Bayesian network can be suggested by experts or updated using the actual Bayes theorem and the new data being collected. There are two components which are involved in learning a Bayesian network. Structured learning, this involves discovering the DAG, directed acyclic graph, in case we forgot, that best describes the causal relationships in the data, and parameter learning, this is the second component, which involves learning about the conditional probability distributions. Now, the difference between Bayes' theorem is one simple. Between Bayes' theorem and naive Bayes, the difference is that naive Bayes assumes conditional independence, whereas Bayes' theorem does not. That means that the relationship between all input features is independent in Bayes' theorem. The difference between Bayesian network and naive Bayes assumes conditional independence, whereas Bayes networks allows the user to specify which attributes are conditionally independent. Let's not confuse Bayesian networks and Bayesian theorems. These are some of the important references which I used to make this research, and the link to the dataset and my GitHub will be in the description of this video. Thank you for watching.